Hello everyone, I am so excited that you have joined us for our lesson today. Today we are going to be investigating number sequences. This falls under the greater mathematics section of sequences and series. Great, so I'm going to ask you a question. Have you ever thought about number patterns that occur in real life? Maybe your mate is always late and you say, well, it's a pattern of theirs to always be late. Today, we are going to look at mathematical ways to explain patterns and also predict further possibilities and outcomes of patterns. Great, so we're going to have a look at the board. Our concept map for today has specific concepts or words that I'm going to define throughout this lesson, and then later on we're going to look at some examples that explain each of these. So let's have a look at our first concepts. The first concept that we are going to be looking at today is the word term. A term refers to each item that makes up a sequence. Now you may ask, but what is a sequence? A sequence is a set of numbers in a specific order that are formed by a mathematical rule. So here we can see the connection to maths. Why? Well, you may be thinking, well, can I see an example of this? Let's have a look at an example where we can see a term and a sequence. So please, will you follow me on the board? If I have the numbers 2, 4, 6, 8, and 10, I could say that this is a sequence because I have a set of numbers in a specific order. So here I've got a set of numbers in a specific order, and if I'm trying to look at a term of the sequence, a term refers to each item that makes up a sequence. So 2, 4, 6, 8, 10 is my sequence, but it's made up of certain parts. So 2 is a term, 4 is a term, 6 is a term, 8 is a term, and 10 is a term. Each of these make up the sequence. The next concept that I'm going to be looking at is something called a common difference. This is the main property of an arithmetic sequence. Let's have a look at the actual definition for common difference. So please look at the board with me. Common difference is a value that is continuously added, so you can even put a little plus in your notes, or it is continuously subtracted between successive terms. So if I think about the example I had on the previous slide, I had 2, 4, 6, 8 going on. I'm sure that everyone will agree with me that between these terms, I have a common difference. So I'm going to ask you to think at home, what is the common difference? Hopefully, you're going to agree with me that I've added 2 between each of these terms. Because I've added 2 between each of the terms of the sequence, my common difference is 2. And again, I'm going to repeat that the property of a linear pattern is the fact that there is a common difference present. Let's have a look at another example. So we are given the pattern 1, 4, 7, 10, 13, 16, 19, 22, 25 going on. Everyone, I want you to think at home. Is there a common difference for this pattern? I'm going to give you a couple of seconds. Is there any value that's being added or subtracted between each of these terms? Is it the same value? Okay, I'm hoping that I'm hearing some mumblings of maybe a 3 being thrown around. Let's have a look at the board. Between 1 and 4, I can see that I added 3. Between 4 and 7, I added 3. And look, again, between 7 and 10, I added 3. Between 10 and 13, I added 3. Between 13 and 16, I added 3. And continuously through this pattern, I can see that I'm adding 3 between each of the terms. So, what does this mean for my sequence? We defined common difference as a value that is continuously added or subtracted between terms. In the example behind me, you can see that we continuously added 3. So, what is my common difference? Positive 3. So let us write that down. Our common difference is 3. Because I have a present common difference, it is a linear sequence. And in our next lesson, we are going to be looking at more different types of patterns or ways that we can actually write mathematical rules to describe what we are seeing in a pattern. But I will see you guys after the break.